Okay, so we're back after lunch. We're on to the cold hardiness and climate change presentations. To kick us off is Dr. Harrison Wright from the Kentville Research and Development Center, and he's going to be speaking on Activity 7 cold hardiness programs. Take it away.
Right. You can hear me all right, Jesse?
Yeah, we can hear you great.
Perfect, thanks. Sometimes I'm a couple minutes in before I find out otherwise. All right. First of all, thank you for this opportunity. I'm glad to be able to talk to you all today. Focusing on Ben Min, I see. Wine grape cluster activity 7B, winter hardiness, topic of great importance. I'm going to make one clarification here. This is activity 7B. There's actually activity 7A. This is a collaboration between an AAFC researcher, myself, and Jim Wellworth of Covey, so a non-AAFC researcher. So he's 7A, I'm 7B. We were working on the same objectives. So, here we go. So my name is Dr. Harrison Wright. I'm a research scientist here with Agriculture and Agri-Food Canada, here located on the East Coast at the Kentville Research and Development Center, which is located in Kentville, which is located in the Annapolis Valley, Nova Scotia. So a couple pretty pictures. Most of the viticulture, most of the vineyards in Nova Scotia can be found in a place called the Annapolis Valley. Those of you who aren't familiar with Nova Scotia, Annapolis Valley is a large alluvial valley, over 125 kilometers long, approximately 12 kilometers wide, give or take. Very good fertile soil. This is actually a picture of the farm I grew up on. We did not have vineyards, but we grew apples, berry crops like highbush blueberries, strawberries, and things of that nature. So most of the vineyards can be found in the Annapolis Valley, but they can be found lots of other places as well. And we had sites that we did a bunch of work. So this is a lot of places where we had sites. There's also a lot of sites in the Gaspereau Valley and a lot of grapes in the Gaspereau Valley. It's adjacent to the Annapolis Valley. A much smaller valley. It's only 15 kilometers long and a few kilometers wide. We had a number of sites, and we had a number of sites there. We also had sites down the western end of Nova Scotia. Some of you might be surprised to know that many of the first grapes propagated and cultivated in Canada were actually here in Nova Scotia. This would be one of the places where that happened over 400 years ago, or approximately 400 years ago, I should say. Early 1600s. This is a picture of Bear River. We had sites down there as well. I say we propagated grapes 400 years ago. This is mostly done by wealthy ship captains, wealthy merchants. But this was something well short of a wine grape industry. I'm not saying we've had a wine and grape industry for 400 years, but these were, some of the elite, and they grew grapes and kind of bragged about it back home to their family in Europe. And we know about that because of some of the letters that they would write. We also have a number of sites on the South Shore. There's a picture of Mahone Bay. It's famous for having 3 churches of different denominations right in the row. So a bunch of grapes. This is on the open ocean, the Atlantic Ocean. So there's also grapes growing down there, a little bit inland though. So a little caveat before I get into the what we actually did. If nothing else, the 5 years that was this wine grape cluster project demonstrated how important wine grape hardiness is to viticulture in Canada. So I'm just going to go through what happened here in Nova Scotia. June 3rd, 2018, we had a -2. That was the coldest June temperature on record here in Nova Scotia. That record goes back over 100 years to 1913. We lost 50% of our crop. February 15th, 2020, we had a temperature that was sub -25, which is a pretty cold temperature for grapes, especially vinifera. It was a temperature inversion though, which means some sites got hit pretty hard, but the majority of sites, were spared. So a temperature inversion, quite variable. Kentville, the research center, we were one of the sites that were hit quite hard actually. January 22nd, 2022, so 2 years later, we had a very similar event, again, a temperature inversion. Again, there's some loss of crop. Some people got hit very hard, complete loss of crop, but a number of sites, were spared. In February 3rd, 2023, this was the big one. This is the one right at the end of this project. And it was also below -25. The difference between this and the 2 previous events was it hit everybody. All of Nova Scotia got this. It was not a temperature inversion. It came with wind, much like BC's more recent event. And Lasted nearly 2 days, and everyone was hit. We lost a lot of our crop. The most insidious thing about this event was how warm that winter had been up until that point. This was the warmest start to winter on record, and that was half the damage right there, is how unprepared these vines were when we finally got this cold temperature. So that's just Nova Scotia. I don't need to talk about the growers in BC about these last few years. Ontario and Quebec, had less headline grabbing events over these past 5 years as well, but also pretty serious events. So getting into what we did as part of the CAP Activity 7B project, 3 objectives we had here in Nova Scotia. So one was just coordinated bud hardiness survey. So as part of the wine grape cluster, there was projects in all of the main wine grape growing provinces, Ontario, BC, Quebec, and Nova Scotia, that were doing the exact same thing. And that was going out weekly or bi-weekly and measuring the hardiness in their vines in a key basket of vines, I'll call it. So what do I mean by this? You guys probably seen this before. We measured bud hardness via something called differential thermal analysis. We would go weekly or bi-weekly. We collect canes, we bring them back, we cut off the buds, and we measure their freezing point. And then we make graphs that look like this, which is what we use to show the hardiness of our vines throughout the dormant season. So on the x-axis, we have the date throughout the dormant season, November to April. And the y-axis, we have what we call the LT50 date, low temperature exotherm 50. This is the temperature at which 50% of your buds will die. So in Nova Scotia, we did 5 different cultivars. 3 of them were vinifera. We looked at Chardonnay. Here's a plot of our Chardonnay over 5 years. We looked at Riesling. Very similar looking plot, not hardier than Chardonnay, at least as it's grown in Nova Scotia. And then we looked at Pinot Noir. Again, very similar in hardiness. If anything, it's a little bit hardier late in the season. And this just goes to show you that bud hardiness is only one element of vine resilience and hardiness, because I can tell you out of those 3 vinifera in Nova Scotia, the Pinot Noir is the least happy. But in terms of bud hardiness, it actually showed to be a little bit hardier than the other 2. Then we looked at some key hybrids. We grow about 70% hybrids here in Nova Scotia. Our number 1 hybrid is something called Lacadie. And this is the hardiness of Lacadie relative to the 3 main vinifera that we grow. So it is actually a fair bit hardier. Same shape of that plot in terms of its hardiness throughout the winter, but a little hardier. Lacadie is not especially hardy for a hybrid, though. An example of a hardy hybrid, we also included Minnesota variety Marquette. You can see again, same plot, only even hardier again. So that's a cultivar that's bred for winter hardiness. And so I'm going to take a second to look at this plot, and I'm going to make the point, this plot, counts, for these cultivars, or for winter hardiness in general. There's 2 things that will decide, 90-95% of how hardy your vine's going to be. One's genetics. You can see how different it is between cultivars. The genes impart a certain level of hardiness. Another main driving factor is the average temperature. The average temperature of where those vines are grown determine the hardiness of those vines in combination with the genetics. So that dotted line I just put up there, that's the average temperature over those same 5 years. And you can see that plot exactly mimics the nuances of it, the hardiness plots. If I were to drop it down over the vinifera, you can see it could practically be just another vinifera vine. That hardiness is directly driven by the average temperature. That's the main thing driving your hardiness. The hybrids, very similar, just a little bit more exaggerated. This is another point I want to make. We probably won't be able to do this forever. We did this, and we're doing a little bit more. We've collected a lot of data, but this plot that I just showed you, this required 3,250 people hours to create in terms of the sampling, the measuring, the analysis, and then putting this plot together. That last part wasn't too bad, but it takes a lot of time. And that's why we're trying to move away from manually measuring the hardiness. Again, it's very manually, or requires a lot of work. And so we've taken this data. A lot of the researchers that were part of this cluster, they took their data, as well as a bunch of other researchers throughout northern regions in the U.S. and some southern regions, actually. And the future is probably going to be modeling the hardiness, not always measuring it. So this is one example of that. This is a paper that came out during the cluster, and it's called the NYUS.2 model. There's other examples of this. Other people have had other attempts. This is a pretty good one, though. It's a machine learning prediction model. It's led by Cornell, or a group of some researchers at Cornell University. if you squint really, and you can see my name and my technicians way down there on the list of authors. There's a bunch of other Canadian authors on this paper as well as a bunch of American authors. And yeah, so moving on to objective 2. So objective 2 for this project, I'm going to say it was basically everything that was included in objective that wasn't part of the survey. So a bunch of things that we looked at in terms of the factors that affect winter injury and winter hardiness. So the first thing we did was actually a little bit of a survey in itself as well, but a much bigger one, although narrowed only for the peak of winter. And so instead of looking at 5 cultivars, we looked at 16. We only looked at the peak hardiness, and we did it over 2 years. I really just want to look at, you know, the breadth of hardiness and vinifera that we grow here, as well as the breadth of hardiness and hybrids. So the hybrids, you can see them in blue. They really separate out quite nicely, and the vinifera are in red. So it doesn't matter how you're going to interbreed those vinifera. They just don't get that North American genetics that imparts that bud hardness that you see in the hybrids. That's the main point I wanted to make with that plot. We did a bunch of other trials. One of them was implications of harvest timing, especially in Nova Scotia, where our season is so short. We wonder, like, there's not a lot of time post-harvest for these vines to recuperate. We were wondering how that affects the vines. There's a bunch of studies that have done this before that showed not a lot of difference, but here in Nova Scotia, we did see some differences. This is some Riesling. The ones on the left, we harvested early. For a sparkling wine, you can see they're already turning yellow, the leaves and senescing, and the vines on the right of that post, that's late harvested. They still have fruit on them, and you can see those vines are holding back. They're not, their leaves haven't senesced as much, and their buds aren't as hardy. So it can make an impact. It depends on the year. Implications of pruning timing. We also did, this is a bit of a serendipitous trial. We looked at harvest timing. We inadvertently looked at harvest timing. We had pruned some vines in mid-December, and we had pruned some vines in mid-March as part of another study. And this is the year that we got that polar vortex. You can see a lot of the vines that we pruned in mid-December, which was, again, one of our warmest Decembers on record. They got hit very hard, and the ones that we waited till afterwards, they did not get hit so hard. So there's kind of like conflicting information in the literature on this, but this is a demonstration of how the timing of your pruning can affect the hardiness of your vines in some years. There's more to that story. I don't have time to get into it. I already alluded to this, but the implications of winter warming. So winter warming, we know the winters are getting warmer. The winters are actually warming faster. It's actually the fastest part of the season that's warming here in Nova Scotia. You know, it's warmed nearly 2 degrees over the last 100 years, but the winter season has warmed nearly 5 degrees. So on the one hand, this means less cold temperatures, but on the other hand, you know, capable of doing freezing damage. But on the other hand, it also means the vines aren't acclimating as much. This is an example of that. This is Marquette hardiness again. On that line shows the hardiness at the beginning of winter. This is actually before the polar vortex. This is what the hardiness should look like in Marquette going into winter. You know, it gets hardier and hardier as you go into the deepest part of winter. But in 2022, 2023, this is what our vines look like. So we were off nearly 3.5 degrees in hardiness. So Marquette, Minnesota variety, is claimed it can grow in Quebec. You know, it can handle temperatures minus 35 and colder, but not if you grow it in a warm region or in a warm year. So this year, vine, the Marquette, which can handle very cold temperatures because it was so warm that year, you know, we saw damage at minus 25 and minus 26. You're still better off than having vinifera, but you know, this is the double-edged sword of climate change. Post-freezing trials, we had lots of opportunity to do this, so we did some work on that as well. I don't have time to get into it, but you know, different ways to prune your vine after you've had freezing damage. And finally, just a few words on objective 3. This is a Chardonnay clone trial, and unfortunately, I say ending on this because it's a bit of a low note, but we looked at a bunch of different clones and how their different relative hardiness. And I can say Chardonnay 95 appears to be the hardiest of the Chardonnay clones. But I will say that's an activity 7A finding. That was Jim Wellworth. He had done that a lot longer, and so that's the finding he had. We weren't as lucky in Nova Scotia. We planned to plant in 2020. I don't know if you guys would likely remember good year for things going as planned. We had ordered the vines. We had canceled them a week before they arrived in March. For the same reason, we had supply disruptions in 2021. We finally planted in 2022. And then we received what we called the polar vortex in 2023, and it killed actually everything. Couldn't find any differences because those vines are only 6 months old, and they got one of the most severe winters we've ever had here. One of the most severe winter freezes we've ever had. Anyway, that's it for my talk, and yeah, thank you for your time.